Hi guys, this is Chohardi from ACE Academy, and today we're going to be talking about Chemistry Paper 1 MCQ from October-November 2022, Variant 1-1. Yeah, so let's get started. Question number 1 says, which row shows the most appropriate apparatus for the measurement given? The most appropriate apparatus. Option A is 25.0 cm cube of solution in a measuring cylinder. One thing to note over here is that they want 25.0 cm cube of solution. Like when the 25.0 is there, when the 0.0 is over there, they want something which is more accurate or exact. But in a measuring cylinder, we cannot measure the exact volume or the accurate volume because measuring cylinder is not accurate. As a result, option A is not the answer. Option B is 32.7 cm cube of solution in a pipette. Well, in a pipette, we can only measure fixed volumes of liquid like 25 cm cube of liquid or 50 cm cube of liquid. But we cannot measure something like 32.7 cm cube of solution. And then we have 75 cm cube of gas in a gas syringe. And we know that this is possible. But in option D, they have given us 80 cm cube of solution in a burette. One thing to note over here is that with the 80 cm cube, the 0.0 is not there, right? It's just plain 80 cm cube of solution. This represents that they do not want an exact volume of a solution. They just want an approximate 80 cm cube of solution. But in a burette, we know that burette is well known for its exact measurements, for its accuracy. As a result, since burette is more accurate, we would obviously want something like we would of course measure something that has a decimal value in it with the burette, not something like 80 cm cube which doesn't have a decimal value with it. So answer is option C. Question number 2 says a liquid X is distilled from a mixture using the apparatus shown. During the distillation, the thermometer reads from 157 degrees Celsius to 160 degrees Celsius. This is very important to note because they have told us that during the distillation process, the temperature doesn't remain constant, right? The temperature varies between 157 degrees Celsius and 160 degrees Celsius. But we know that for something that is pure, the boiling point of a pure substance will always be exact and it will not vary. As a result, we can understand that liquid X is a mixture and not something that is pure. It is a mixture of liquid. So option A says the liquids in X may or may not be miscible with each other, and this is correct. Option B says X is a mixture that can be separated by distillation. Note that we have already carried out the distillation and still received a mixture that is not pure, right? We have already received liquid X after the distillation process, and we know that liquid X is still a mixture and the pure elements or the pure substances cannot be separated from liquid X. As a result, option B is not the answer. C says X must contain two liquids with boiling points 157 degrees Celsius or 160 degrees Celsius, which we know that is not correct. This is not correct because we don't know exactly how many liquids are present and we don't know the exact boiling points as well, because the question says that the temperature varies between 157 degrees Celsius and 160 degrees Celsius, but it doesn't say that it remains exactly at 157 degrees Celsius or exactly at 160 degrees Celsius. As a result, option C is not correct, and option D says X must have been obtained by the fractional distillation of petroleum or crude oil, which is not correct. As a result, the answer is option A. Question number 3 says, an aqueous solution contains a salt Y. Addition of an aqueous solution X results in a precipitate being formed that redissolves when more X is added. Note that we only carry out this kind of a procedure when we are testing for cations, right? So we have to notice that we added an aqueous solution X, and we know that for testing out which cations are present in a solution, we always add aqueous solution, which is either sodium hydroxide solution or aqueous ammonia. So HCl and sulfuric acid is not the answer. It has to be aqueous ammonia. I mean sodium hydroxide solution, sorry. And for the second part, they have told us that the precipitate, after the precipitate is formed, the precipitate redissolves when more X is added. Like the precipitate dissolves in excess. Dissolves in excess. This suggests that we know that copper, it doesn't redissolve when sodium hydroxide is added. As a result, option D is the answer, because we know that zinc sulfate, like the zinc ion, when sodium hydroxide is added in excess, the precipitate that forms redissolves. So option D is the answer for question number 3. Question number 4 says, which gas diffuses the fastest at the same pressure? The same pressure. For a gas to diffuse fast, we have to note two things. First of all, it's RMM, and secondly, the temperature. The RMM has to be as low as possible, and the temperature has to be as high as possible. So 25 degrees Celsius and 25 degrees Celsius is not the answer. 50 degrees Celsius is the answer. But we can see that for nitrogen, our RMM is lower than for oxygen. As a result, option B is the answer. For question number 5, the question says, the diagram shows the outer shell electrons of the atoms of two elements Q and R. They have given us this diagram, a dot and cross diagram. From the diagram, we can see that Q has 2 electrons in its outer shell and R has 7, right? And this represents the nucleus and X represents an electron. The sulfate of Q is insoluble, and element R is a gaseous substance at room temperature and pressure. We know that for sulfates, according to the solubility chart, we know that for sulfates, barium, calcium, and lead, these are insoluble. These are insoluble. So from here, it has to be something like barium, calcium, or lead. We know that the proton number for barium is 56, and it is pretty obvious that the option lies somewhere in between option C and option D. And the relative atomic mass of R is given, and we know that we have been told that element R is a gaseous substance at room temperature and pressure. Since it has 7 electrons in its outer shell, we know that it lies in group 7, and from group 7, only fluorine and chlorine are gaseous substances at room temperature, right? As a result, the answer will be option D, because we know that the relative atomic mass of chlorine is 35.5, and chlorine is a gas at room temperature and pressure. For question number 6, it says, which statement about iodine atoms and iodide ions are correct? They are both isotopes of iodine. They undergo the same chemical reactions. They have the same number of protons. They have the same physical properties. We know that they are not both isotopes of iodine, because isotopes mean the number of protons have to be same and the number of neutrons have to be different, or the mass number has to be different, right? But for iodide ions, the mass number and the proton number both are equal. Like both the atomic number and the mass number is equal. And in option B, it says they undergo the same chemical reactions. We know that they do not undergo the same chemical reactions, because the number of electrons in the outer shell of iodide ions and iodine atoms are not equal because iodide ions have gained electrons and iodine atoms did not gain any electrons, so the number of electrons in its outer shell is different. So option B is not the answer. They do not undergo the same chemical reactions. Option C says they have the same number of protons, which is correct, and option D says they have the same physical properties. They do not have the same physical properties because we know that when iodine exists as an iodide ion, it is of course bonded with some other element. As a result, it is a substance that is not iodine. It is a compound, right? And iodine is an element. As a result, they will not have the same physical properties. So 6 is C. Question 7 says the element chlorine has two isotopes, chlorine 35 and chlorine 37. In the periodic table, chlorine is shown as 35.5, which row shows the correct percentage of each isotope in a sample of naturally occurring chlorine. We know that here is 35, here is 36, and here is 37. And we know that in the periodic table, they give the mass number of chlorine as 35.5, which we can see that is much closer to 35 than 37. This is much closer to 35. As a result, we are sure that the number of chlorine 35 atoms is more than the chlorine 37 atoms in a given sample. So we can be sure that percentage of chlorine 35 atoms is more in a sample than chlorine 37. So option A is not the answer, option B is not the answer, option C is not the answer, and option D is the answer. What is the nuclear number of the isotope of uranium atom? We know that the nuclear number is the mass number, which is given as 235 in the periodic table. So the option C is the correct answer. Silicon dioxide has a giant structure. Each silicon atom is joined to 4 oxygen atoms by covalent bonds. Part of the structure is shown. Which property would silicon dioxide be expected to have? A good conductor of electricity. We know that in a silicon dioxide structure, all the outer shell electrons are used up in bonding. As a result, silicon dioxide does not have any free electrons or ions that can conduct electricity. As a result, this is not correct. Option B says it has a high melting point. Since this is a giant covalent structure, giant molecular structure, we know that it must have a high melting point. It reacts with hydrochloric acid. No, it does not react with hydrochloric acid because from the reactions of an acid, we know that silicon dioxide does not react with an acid. As a result, option C is not the answer. And it is soluble in water? No, because we know that giant molecules are not soluble in water since they are non-polar. As a result, option B is the answer. Question 10 says elements X and Y react to form compound XY. Element Y has more electrons in its outer shell than element X. Compound XY conducts electricity in the molten state, which row correctly states the electron change that occurs during the reaction and the type of bonding in compound XY. We know that compound XY conducts electricity in its molten state, and this can only happen when the compound is an ionic compound. So the answer is somewhere between option A and D. And in an ionic compound, we know that ionic compounds are written in a way that the metal is shown at the first and the non-metal at the second. So first we have the metal and then we have the non-metal. And ionic compounds are formed when metals and non-metals react. As a result, we know that since X is represented at the first, As X is represented before Y, we can be sure that X is a metal and Y is a non-metal. And X, being a metal, donates its electrons to Y. So X donates electrons to Y is the answer. Question 11 says, which compound has the most single bonds in one molecule? And we know that for option A, the structure is something like this, where all these are hydrogen and we have the two carbon atoms in the middle. As a result, we can be sure that this compound has 7 single bonds. Next we have this substance, which says we have 2 carbon atoms in the middle and then we have this OH and we have the hydrogen atoms over here. So we can see that this structure has 8 single bonds. And for option C, we can see that carbon has these 3 hydrogen bonds and then yeah, so this is the structure and we can see that it has 5 single bonds. And then we have option D. No, wait, this one actually has one more single bond over here, so there are in total 6 single bonds. And then in option D we have something like this. Wait, so in option D we have something like this. Three carbon atoms in the main chain and then we have these hydrogen atoms over here. So we can see that this has 4, 5, 6, 7 single bonds, right? So this one has the most number of single bonds. Option B is the correct answer. Question 13 says, which mass of oxygen combines with exactly 16 grams of sulfur to form sulfur dioxide? And the equation, as we know, is something like this. Sulfur plus oxygen equals sulfur dioxide. So we can see that we have 16 grams of sulfur. So the mole for 16 grams of sulfur will be 16 divided by the RMM of sulfur, which is sulfur has an RMM of 32. We know that the mole for this one is 0.5. And we know that for oxygen the mole shall also be 0.5 and mass divided by RMM gives us mass equals 0.5 multiplied by the RMM of oxygen, which is 16 multiplied by 2, 32, and half of 32 is 16. Option C is the correct answer. And question number 14 says the atomic number of ruthenium is 44. One of the oxides of ruthenium is a black solid. X 5.79 grams of X contains 1.39 grams of oxygen. One of the oxides of ruthenium is a black solid. X 5.79 grams of X contains 1.39 grams of oxygen. So yeah, 5.79 grams of X, right? So we know that for oxygen we have 1.39 grams, and for ruthenium we have 5.79 minus 1.39, which gives us 4.4. Yeah, 4.4. What is the empirical formula of X? We know that to calculate the empirical formula, we first have to divide this by its atomic mass, 16, and for Ru we have 101. This one over here. So 101, and this gives us something like 0.0436 for oxygen. For ruthenium, and it gives us something like 0.87 for oxygen. And then if we divide this with, like if we calculate the simple ratio, we will see that we get 1 over here and we get 2 over here. So Ru is to O equals 1 is to 2. As a result, the correct answer is option C, which is RuO2. And then for question 15, we have 250 cm cube of 1 mole per dm cube hydrochloric acid, which reacts with an excess of solid sodium carbonate. The equation is shown. This is the equation over here. What is the volume of carbon dioxide produced when measured at room temperature and pressure? So we are asked to find out the volume of carbon dioxide. And we know that hydrochloric acid is the limited reagent over here, and we know that to calculate the amount of carbon dioxide we have to calculate its mole first. So in order to get the mole, we have to calculate the mole of hydrochloric acid first, which is in limited. So we know that mole equals concentration into volume divided by 1000, because the volume is given in centimeter cube and not dm cube. So the mole is something like 250 multiplied by 1 divided by 1000. And we get something like 0.25. And if we know that for hydrochloric acid we have 2 molecules, and for carbon dioxide we have 1 molecule. So doing the mole ratio, we get something like this: hydrochloric acid is to carbon dioxide is 2 is to 1. As a result, the mole of carbon dioxide will be something like 0.25 divided by 2. We get 0.125. And we know that in order to get the volume, we have a formula that is volume equals mole into molar gas volume, and we know that the molar gas volume is 24 dm cube. So volume so the volume will be equal to moles into molar gas volume. We get 3 dm cube as our answer. Question number 16 says when excess aqueous barium chloride is added to 25 cm cube of 1 mole per dm cube sodium sulfate, a white precipitate of barium sulfate is formed. So sodium sulfate is added to barium chloride and we get barium sulfate and sodium chloride. The precipitate is filtered off, washed, dried and weighed. 5.36 grams of barium sulfate is obtained. You can see that 5.36 grams of barium sulfate is obtained, and they have asked for which percentage of yield of barium sulfate we have received. So we have to calculate the moles first. So we know that we have to find out the moles. Right. So they have given us the volume and the concentration of sodium sulfate, this one, and we have been told to find out the percentage yield of barium sulfate. So we have to find out how many grams of barium sulfate we are originally supposed to get by using the moles of sodium sulfate. So the moles of sodium sulfate will be something like concentration into volume divided by 1000, and we will get 25 multiplied by 1 divided by 1000, and it will give us 0.025. So the moles of sodium sulfate is 0.025, and considering mole ratio, we know that this one is to, like, sodium sulfate is to barium sulfate, we will get 1:1. So the mole ratio of barium sulfate is also 0.025. So taking the number of moles into account, we will now find out the mass that we are originally supposed to get. They have already given us the RMM of barium sulfate. So to find out the mass, we have to multiply the moles with the RMM. 0.025 multiplied by 233, and we will get 5.825. 5.825, and we know that in order to calculate the percentage yield, we have to divide the mass that we have received in actual and the theoretical mass that we are supposed to receive, and then multiply it by 100, and this will give us something like 92%. We actually get 92.017%, which is close to 92%, so the answer is 92%. Then we have question number 17, which says aqueous copper 2 sulfate is electrolyzed using inert electrodes. Which statement is correct? So inert electrodes, we know that inert electrodes do not react, and we have given copper 2 sulfate. So the ions present in aqueous copper 2 sulfate are hydrogen ions, copper 2 plus ions, hydroxide ions, and sulfate ions. But we know that since copper is less reactive than hydrogen, copper is the one that we will receive at the cathode, and hydroxide ions are the ones that will react or take place in the reaction in the anode. So we know that when hydroxide ion takes place when hydroxide ions undergo reaction in the anode, they produce oxygen. And we know that when copper 2 plus ions uh, when copper 2 plus ions move to the cathode, they undergo a reaction like this. They gain 2 electrons and they become copper. So we know that copper is collected at the cathode, not at the anode, so option A is not the answer. At the cathode, we know that copper is collected once again, so hydrogen is not the answer. Option C says oxygen is collected at the anode. Yes, we know that oxygen is collected at the anode is a correct statement, and sulfur is collected at the cathode is not a correct statement. So option C is the answer. Question number 18 says, concentrated aqueous sodium chloride is electrolyzed using inert electrodes. Which equation shows the reaction that occurs at the anode? Using inert electrodes, once again, we know that inert electrodes are inactive, or they do not take part in the chemical reaction during the electrolysis process. So when concentrated aqueous sodium chloride is electrolyzed, we know that the ions present are hydrogen ions, sodium ions, chloride ions, and hydroxide ions. And since it is a concentrated solution of sodium chloride, we know that chlorine will be the one that we will receive at the anode and not hydroxide. And for the cathode, we know that since hydrogen is less reactive than sodium, we will get hydrogen. So which equation shows the reaction that occurs at the anode will be something like this: Cl minus equals, which is represented by the equation in option A. So the correct answer is option A. Which pair of equations correctly represents the reactions taking place at the anode and at the cathode during the electrolysis of molten silver bromide? Okay, so in here we know that we have silver bromide, uh, the formula for silver bromide is something like this: AgBr. And so we know that when this undergoes electrolysis, undergoes electrolysis, we will get silver at the cathode and bromide at the anode. But we also know that bromide, like bromine, exists as liquid, and bromine is a diatomic molecule. So this must exist as Br2 as a result. So we know that the formula for silver bromide is Ag plus and Br minus. So bromine, as we were talking about, bromine exists as a liquid in its diatomic form. As a result, the equation must be something like this, because we know that uh, there has to be two molecules of bromine to form the liquid. So this equation over here This equation represents that, and this equation also represents that, and this equation also represents that. But the catch is, bromine, we know that bromide ion is an anion, so it must be occurring at the anode. So option D is not the answer. And to understand why, and to understand if option A or C is our answer, we have to see that silver undergoes something like this, undergoes a reaction something like this. It gains an electron and forms silver, right? So this is the electron and not this. So this equation over here is the correct answer, and our option for number 19 is C. Which two processes are both endothermic? We know that combustion is not endothermic, it is an exothermic process, because combustion releases a huge amount of heat energy, as it is always used as fuels. Once again, combustion is not the answer. And we have cracking and photosynthesis over here, which can be one of our answers. And in option D, we have respiration and photosynthesis. We know that photosynthesis is obviously an endothermic reaction because it produces energy. But in respiration, we know that glucose molecules are broken down and energy is released. Since energy is released, it is not an endothermic reaction, it is an exothermic reaction. As a result, the correct answer is C. 21 says a sample of sulfuric acid is added to 10 grams of zinc granules. 10 grams of zinc granules, a reaction occurs and a gas is produced. The rate of reaction is increased if a small amount of copper is added. The copper is unchanged after the reaction. The copper is unchanged and it is added in a small amount of copper. As a result, we can understand that copper in this case is acting as a catalyst. Which statement about this reaction is correct? Copper acts as a biological catalyst in this reaction. We know that copper is not a biological catalyst in this reaction. Copper lowers the activation energy of this reaction, which is true. Copper lowers the activation energy of this reaction and makes the rate of the reaction faster. The rate of the reaction is greater as the particle size of zinc is greater. This is not true because we know that when the particle size of zinc increases, the rate of reaction actually decreases because of smaller surface area. And for option D, we have the rate of reaction is greater if the pressure is increased. One thing to note over here is that 10 grams of zinc granules are added with sulfuric acid. So sulfuric acid is a liquid and zinc granules are solid. But we know that when pressure is increased, the rate of reaction increases only if the reaction is completely a gaseous reaction. But this is not a gaseous reaction since no gases are involved in this process. As a result, option D is not the answer. So the correct answer is option B. Then we have 22. The rate of reaction between magnesium and dilute hydrochloric acid is investigated. The equation is shown. Magnesium plus hydrochloric acid equals magnesium chloride and hydrogen. A known mass of magnesium is added to an excess of dilute hydrochloric acid. The concentration of the hydrochloric acid and the volume of hydrogen produced is measured at regular intervals. Which pair of graphs correctly shows the experimental results? So one thing to note over here is that dilute hydrochloric acid in this case is added in excess, right? Since it is in excess, we know that the volume of dilute hydrochloric acid will never reach zero. Some amount of hydrogen chloride will always remain at the end of the reaction, it will not be completely used up since it is in excess. From here we can derive that option A and option B cannot be our answers. Since the concentration of hydrochloric acid in option A and option B gradually decreased to 0, but we know that the concentration of hydrochloric acid cannot be 0 in our answer because it is in excess. And we know that for the volume of hydrogen, we know that the rate of reaction is fastest at the beginning of the reaction and gets slower as time progresses. As a result, we can see that we are getting hydrogen at a faster rate at the beginning of the time, and slowly the gradient of this curve decreases. As a result, we can see that the rate of reaction decreases, and for this one the rate of reaction increases, which cannot be our answer, so option D is the correct answer. Question number 23 says, in which reaction is the underlying substance reduced? So we can see that in here calcium, it is in a 2 plus state, and even here it is in a 2 plus state, so option A is not the answer. In here we can see that copper 2 plus, it is originally 2 plus over here and then comes to 0 over here. As a result, the oxidation state decreases from 2 plus to 0, so option B is the answer. In question number 24 we see that calcium carbonate turns to calcium oxide. We know that this is a thermal decomposition reaction, so thermal decomposition reactions are not redox reactions, so this is not the answer. Copper to brass is basically turning copper into a mixture. As a result, this is not a redox reaction as well. From ethene to polythene, we get a polymerization reaction, and we know that this is not a redox reaction. As a result, this leaves us with option D, and we know that option D is a redox reaction where sand is reduced, because in here we know that silicon dioxide turns to silicon, and we know that in silicon dioxide, since the charge of oxygen is 2 minus and there are 2 moles of it, like 2 molecules of it, so silicon must be 4 plus, and this turns from 4 plus to 0 because we know that silicon is an element with 0 oxidation state. As a result, this is reduced from 4 plus oxidation state to 0 oxidation state. Option D is the answer. Question 25 says, thiosulfate ions S2O32 minus react with iodine I2 in aqueous solution. This is the equation, and in this reaction the thiosulfate ions dash electrons and are dash. Which words complete gaps 1 and 2? We know that iodine over here is reduced from 0 oxidation state to -1 oxidation state. As a result, thiosulfate ions are acting as reducing agent, so they are oxidized themselves, oxidized, and we know that oxidation is loss, so option C is the answer. 26 says the equation shows a reaction in the contact process, and we know that this is a reversible reaction because of this double-headed arrow, and it is an exothermic reaction as well because the enthalpy change is negative. And we know that if we add more oxygen to it, the equilibrium shifts to the right because the amount of reactant is increasing. And if we increase the pressure, since this reactant side has more number of gaseous moles, which is 3, and product side has 2, we know that increasing the pressure will shift the equilibrium to the right. As a result, option B is not the correct answer as well, and option C says increasing the temperature. We know that in an exothermic reaction, if we increase the temperature, the equilibrium shifts to the left. As a result, option C is the answer. Some medicines contain the magnesium salt of a fatty acid. The fatty acids are members of the homologous series carboxylic acids and contain one carboxylic acid group. What is the carboxylic acid functional group and how many moles of a fatty acid react with 1 mole of magnesium? We know that magnesium has an oxidation state of 2 plus, and this will be the acid part. And since this comes over here, it must have 2 moles of the acid, so it must be somewhere between B or D. And we know that for carboxylic acid the functional group is CO2H of this part because of this part the functional group is CO2H. So this is the answer. 28 says sodium sulfate Na2SO4 and sodium hydrogen sulfate NaHSO4 can both be prepared using aqueous sodium hydroxide and sulfuric acid. And they have given us the information regarding sodium hydroxide, so we understand that we have to find out the moles of sodium hydroxide, which is concentration into volume divided by 1000, and this gives us 50 into 1 divided by 1000 because the volume is given in cm cube and the moles that we get is 0.05. And considering the mole ratio, for equation 1 we have 0.05, and for sulfuric acid we get 0.05 divided by 2 because of the mole ratio, so we have 0.025. And for equation 2 we have the moles for sodium hydroxide as 0.05 and the moles of and the moles for sulfuric acid is also 0.05 because of the mole ratio of 1:1. As a result, if we look at the volume, we see that this is our equation. From this equation, if we derive the formula for volume, we will get something like this: moles multiplied by 1000 divided by concentration. And if we apply this formula, we will see that for equation number 1 we get 0.025 multiplied by 1000 divided by the concentration, which is given over here, which is 1. So we have 25 cm cube. So for sodium sulfate we get 25 cm cube, and for hydrogen sodium hydrogen sulfate we know that this is our mole 0.05, and multiplying 0.05 with 1000 and dividing it with 1 gives us 50. So option A is the answer. And then we get question number 29, which says which substance reacts with dilute sulfuric acid in the preparation of a pure sample of lead 2 sulfate. Lead 2 sulfate. And we know that lead 2 sulfate is an insoluble salt. Following the solubility chart, we know that lead sulfate is insoluble, and since lead sulfate is insoluble, with dilute sulfuric acid, if we add aqueous lead 2 nitrate, we will get lead 2 sulfate. And notice in option B, option C and option D, we are using these options when we are making something, when we are making a salt that is soluble, right? All of these options are used when we are making soluble salts. Like for example, lead foil is generally never used because we know that lead is less reactive than hydrogen. As a result, lead cannot displace hydrogen from its solution. And for lead 2 carbonate and lead 2 oxide, we know that these reagents are These reactants are used when we are trying to make a salt that is soluble in the acid, but soluble in the acid and soluble in the water. But we know that lead to sulfate is not soluble in water. As a result, uh, the last three options are not acceptable, and option A is the answer. This is because this is an aqueous solution, and this is also an aqueous solution, and two aqueous solutions together form an insoluble salt in the process of precipitation reaction. Which statement about sulfuric acid is correct? In the manufacture of sulfuric acid, iron is used as a catalyst in the contact process. This option is wrong because we know that in the contact process we use vanadium 5 oxide as the catalyst and not iron. We use iron in the Haber process. And option B says sulfuric acid is used in some batteries, which is correct. Option C says sulfuric acid is used as fertilizer. We know that it's not correct because sulfuric acid is an acid. We do not use it as a fertilizer. Option D says sulfuric acid is used as a food preservative. This is also not correct. So option B is the answer. Two statements are given. Statement 1, going down group 1 and group 7, the melting point of the elements increases. Statement 2 says chlorine can displace iodine from aqueous solution from aqueous potassium iodide but cannot displace bromine from aqueous potassium bromide. Notice with statement 1, this is not right because we know that for group 1 the melting point doesn't increase increase below the group. Going down we see that the melting point of the elements decrease, but for group 7 this is correct but not for group 1. As a result, statement 1 is not correct. And statement 2 says chlorine can displace iodine from aqueous potassium iodide but cannot displace bromine from aqueous potassium bromide. But we can see that chlorine is more reactive than both bromine and iodine. As a result, it will displace both bromine and iodide. So statement 2 is also not correct. As a result, this is not correct. None of these are correct, and option D is the answer. 32 says a reversible reaction involves a solid reacting with hydrogen. Which of the metals, aluminium and iron, would catalyze the reaction and what is their effect on the position of the equilibrium? A solid is reacting with hydrogen in a reversible reaction. We know that aluminium and iron are catalyzing the reactions, so they're acting as catalysts. But the catch over here is that aluminium is in group 3, right? This is in group 3, and we know that only transition metals and their compounds can be used as catalysts. As a result, iron can be used as a catalyst but not aluminium. So none of option A and B is correct. Only option C and D are correct in terms of the catalyst part. And we know that a catalyst can never affect the position of the equilibrium. It will only help the equilibrium to be reached earlier. Because it makes the rate of reaction faster, so the equilibrium position will be reached earlier, but the position of the equilibrium will not be changed. As a result, C is not the answer, D is the answer. Question 33 states iron is obtained in the blast furnace from the ore hematite. Which statement is correct? Calcium carbonate is used to remove acidic impurities. We know that this is correct. As a result, this will be our answer, and none of these are answers. Three statements about carbon cycle are given. Carbon cycle regulates the amount of carbon dioxide in the atmosphere. This is correct. During photosynthesis, carbon dioxide is produced. This is not correct because we know that during photosynthesis, carbon dioxide is absorbed and used up to form glucose. But carbon dioxide is not produced in the process of photosynthesis. It is only produced in the process of respiration. Combustion of hydrocarbons require oxygen. This is correct. As a result, the answer will be option 1 and 3, which is option B. Carbon is used in the purification of water supply. What is the reason for this? We know that carbon is used for removing any taste and odor. So this is not the answer. This isn't the answer either. Option C is the answer. 36 says octane is an alkane with 8 carbon atoms per molecule. What is the molecular formula of octane and how does its boiling point compare with that of butane? We can see that it is an alkane, and we know that for alkanes the general formula is CnH2n plus 2. CnH2n plus 2. As a result, since butane has 8 carbons in its main branch, we can say that the formula is C8H2H16 plus 2 gives us 18. So somewhere between C and D. And we know that for homologous series, as the number of carbon atoms increase, so butane will be over here and octane will be further below. We know that as we go down the homologous series, the melting point, boiling point increase. As a result, the boiling point of octane will be higher than the boiling point of butane. So option D is the answer. Then we have question 37, which says which equation for the reaction between propane and chlorine is correct. So propane is an alkane and chlorine, we know, is in the group 7. So when alkanes and halogens react, we know that alkanes and halogens react and they form hydrogen halide. And the chlorine is also displaced, right? This takes place in a displacement reaction. So one of the hydrogen atoms from the propane is displaced by a chlorine atom. So we know that in a propane we will originally have 3 carbon atoms, and then we'll have 8 hydrogen, and this will give something like C3. The number of carbon atoms remain unchanged, and one of the hydrogen atoms will be displaced, so it will become 7, and in place of the hydrogen we'll have a chlorine atom. So from here we can see that option A is not the correct answer, because over here it's a propene, it's an alkene and not an alkane. And we know that over here hydrogen halide is not produced, only hydrogen is produced, so this is not the answer, not even this one. And here we have the hydrogen halide we are looking for, and we also see that one of the hydrogen atoms have been displaced by one chlorine atom. So option D is the answer. Propanoic acid reacts with calcium carbonate. The products of this reaction are calcium propanoate and carbon dioxide and water. This is basically an acid and a carbonate reaction. Acid plus carbonate. What is the equation for this reaction? We know that for calcium we have an oxidation state of 2. So when it reacts with the acid, once again the salt it will form, this part will automatically have 2 moles. So the option is either B or D, since we have a 2 over here. And we know that we have been told that propanoic acid reacts. So propanoic acid will have 3 carbons in its main branch. Here we have 2 and here we have 1, so you can see that this has 3 carbons, but in here we have 3 carbons plus 1 carbon, so 4 carbons. So this is not the answer. Option B is the answer. The monomer CH3CH3 can be used to make an addition polymer. Yes, this is true because of this double bond in here. This addition polymer has a chain of carbon atoms joined to each other by carbon-carbon single bonds. Each of these carbon atoms is also bonded to at least one other atom or group of atoms. These are called side groups. Which statement describes the carbon atoms in the polymer chain made from CH3, CH3? If we draw the structure, we know that we have been given the structure of, yeah, when we polymerize this thing, we get something like this. So this was the original monomer. This is the monomer, which has, yeah, this is the monomer, and when we polymerize this, it becomes something like this, right? As a result, we can see that every carbon atom in the chain has one CH3 and one hydrogen atom as its side group. So option A is the answer. Which row correctly shows the structure of a polymer and the monomers from which it is made? Option A says we have this OH group over here and we have this NH2 group over here. And we can see that this is not the correct answer, because if this is the monomer, one side of it must have this part and one side of it must have this part, but in here both of the parts are having this carbon and oxygen double bond. This shouldn't happen, and both of these parts are having this NH single bonds. This shouldn't happen. So this is not the answer. And in here we can see that carbon in this part has 1 2 3 4 5 bonds, but we know that carbon should only have 4 bonds. So this is not the answer. Over here we can see that there are 2 monomers and it should form an amide linkage, because we have the OH group over here and we have the NH2 group over here. So it should form an amide linkage, but we can see that over here it did not get an amide linkage. It should have been something like this, but we have this oxygen in here which shouldn't be in. This oxygen atom destroys this amide linkage structure. As a result, this is not the answer. And for option D, we have this OH structure over here, this alcohol functional group. So this is supposed to form an ester linkage, and we know that this is an ester linkage, so this is correct. As a result, option D is the answer. So that's the end of the paper. Thank you guys for being with us.